We've got audio and everything working. So good morning or good afternoon, depending where you're at. My name is Kevin Porman. I'm a developer evangelist here at Salesforce, and we're going to be working on Apex recipes today. Now, if you're new to the Apex recipes environment and to codeLive, we've got audio and everything working. Good morning or good afternoon, depending where you're at. My name is Kevin Porman. I'm a developer evangelist here at Salesforce, and we're going to I should close my own streaming monitor so that I don't get that feedback loop. Sorry about that. It's been a morning. We'll put it that way. When we last left Apex Recipes, we were talking about what Apex Recipes is and what it's good for. Apex Recipes is a sample app, which means this is a collection of code designed to teach you the right way to do things in Salesforce. Now, as you might imagine with Apex Recipes, all of these are about Apex, and we've got these broken down into lots of little categories over here, like asynchronous Apex and data recipes and file recipes, etc. When we were here last week, we worked on approval process recipes, and that turned out to be interesting. The approval process schema can be a little confusing at the first get-go. But today we're going to be working on something a little bit more interesting called limits. The limits namespace is something we're going to play around with today. And we're going to be working with the limits to build a couple of things. The first one I want to build with you is a sort of a profiler. If you've ever gone into and read your logs of a Apex transaction, you'll see that at the bottom of it we did 5 DMLs and 3 queries and 16 counts to 20 or whatever. And we're going to be building something a little bit more tailored to us. One of the things that people have come to me with and they've said is, Kevin, I've had this process or this batch process or this trigger or something, and it's been working fine for 8 years or however long, and now I'm getting a CPU timeout. Well, we're going to have this in order to be able to sort of profile what it is we want to figure out what's taking so long. So to do that, we're going to dive into the code here. Now, I've created a folder called limits recipes, and so I'm going to create a new class, and we'll give it limits recipes as a name. Choose the custom directory because we want to put it in our limits directory class. Bump, bump. Okay, now the limits recipes is we're going to demonstrate how we use the limits namespace and all of its various functions. So I'm just going to create a couple here to give you an idea of how these work, and we're going to just go in and dive right in here. So with that said, we'll do public static void, and we'll say we'll do get get queries like this. And now the limits class itself, and by the way, let me put a link to that here in the code base. So this uses the like that. Well, that did not do what I... Give me the doc block. Come on, tools. There we go. Demonstrates how to use the limits namespace / class methods to react to the possibility of hitting a governor limit during the next step. Okay, we don't put those in there. Boom. All right, so I will put the doc link. Salesforce docs. Boom. Okay, got that going. Now, just as an example of how this works and give us something that we can call that we'll call in this limits, what we're going to do is we're going to call a pair of methods on the limits, and we're going to get back a list of, or excuse me, a number of queries that we've run versus a number of queries that we can run. So when we do this, we're going to look at look at this file here, this URL that I sent, and we're gonna pull in and we're gonna say get queries and get limit queries. So let's just dump those to the screen. We'll do system debug and and this is gonna be get queries. There we go. And we'll do limits.get queries. All right. Now, if you notice that there's a ton of things in here. Limits dot, you can get query locator roles, there's a whole bunch of things here. Let me expand this. You can get all sorts of things in here. Get DML rows, get CPU time, etc. But what we're going to do is I want to illustrate what the difference in these two naming conventions give us. So we have system.debug, and we'll do that one. This is going to be get limit. Is it limit? Yeah, limit queries. And this is going to be limits.get limit queries. There we go, like that. And just for grins and giggles, I'm going to open up another tab here. It's not a new file, it's just another tab. And what I'm going to do, I got to save this first. And I'm going to do limits recipes dot, and what do we call that method? Get queries. Okay. Get queries. Woohoo. Okay. And our output shows that it added those just fine, so we didn't have any errors there. And what we're going to do is we're going to run this using execute anonymous. So execute anonymous with the currently selected text. We'll do that. Row. Execute anonymous failed to run. Unexpected token. Public static void get queries. Limits recipes dot get queries. That should be fine. Why are you being mean to me? Execute anonymous with currently selected text. Okay, there we go. I just needed a semicolon. All right, now you'll see here in our logs that we have this get queries, get limit queries. And what this shows us is, I'm going to flip back over here. Get queries is going to show us the number of queries we have already run. Okay, and get limits queries is going to be the number of queries we're allowed to run in this transaction type. So you imagine if you are in like a batch class or a queuable, you have different governor limits than you do if you're in, say, a trigger or like an OR controller. And so with these two things here, what we can start to do is we can start to build out a sort of profiling class that can help us when we're trying to figure out what in our transactions is running so slowly, or what may or may not be running so slowly. So what we can do here is we can take this and we can say, let's build out a method here, and we'll say public static void profile. And in here, what we can do is we can do one big system debug, system.debug. Log level is going to be system dot, is it log? Logging level dot, let's do this one as debug. And now what we're going to do is we're going to put this, we're going to have a /n, which will give us a new line. And then I'm going to give us a 5 dashes, and I'll do another new line. And so that's going to give us a blank line, dashes, a blank line, a line return after it, so that what we can do is we can turn around and easily find these in our logs. So what we're going to do, and actually what I'm going to say is I'm going to say this is profile data, like that. And I can't do multiple line returns inside a single debug statement. So what I'm going to do is I'm going to put a plus there, drop that down one, and I'm going to say, actually I'm just going to format this a little bit better. Here we go, our first line, and then we'll have our second line. And what should we say? We should do percentage of queries, like that. And here, what we can put on the end of this is, and just before I forget, I'm going to put a /new line so we don't forget that. Plus there, because I'm going to go to the next one. But right after this one, I can do, I'm going to put parentheses here, and then I'm going to say limit.get limit queries minus limits.get queries. And then we'll put a plus sign there. Okay, so this is going to say percentage of queries is limit get queries minus the numbers we've already run, and that occurs to me that that is a number of remaining. So we should probably do the math on that one. Let's do this. Let's see, to get the percentage, we're going to take the denominator. Math is hard. Let's go shopping. Do that. And then on this next line, we're just going to pretend that we have end profile data. Like that. There we go. Save that again. Now what we'll do is we'll go over here and we'll run profile. As soon as this gets done, we'll do execute anonymous with currently selected text. And let's look at our logs. Percentage of queries, 0. Well, that's true because we haven't made any queries. That's true. So let's make a query. List account. Select ID from account. Execute anonymous. Execute anonymous is running really quickly today. I'm really impressed with this. So this is going to be 100%. Let's look at our math there. That's probably not right. So get queries will tell us 1 times 100. That's not what we want. We want calculating the percentage. This should give us 1%. Math is hard. Okay. So let's look at that. And then, so limits, get queries, to be 1 times 100. Let's do this. Divided by. Like that. Doop. Okay. Let's rerun that execute anonymous. One divided by 100. It should be 1/100th. That's not right. Times. This is the kind of time where I'm like, how do you calculating percentages? Basic math. Let's see if I've forgotten how to do this. 1 of 100. 1% of 100. This is too bad. Nope. You know what? We're going to use remaining. There we go. Math is hard. There we go. Probably didn't help that my 2-year-old kept me up till 3:30 in the morning. Let's save this. Let me just refactor that a little bit. don't have anything in the chat going on today. You can always feel free to spit something out of the chat. Give me a hard time for forgetting how to calculate percentages, or just ask a question, as it were. As a reminder for people who are just now checking in, we are working on the limits namespace today. We're going to build out a little bit of a profiler, and then we're going to figure out where we might want to use this and why. I just had a thought. Let's look over here in the here we go. I'm wondering, Apex deconstructor. Can we build a deconstructor? Trigger bipper. Add destructor to Apex classes. No destructors. Okay. All right. So we can't do a destructor in Apex. That's fine. My thought was it'd be really cool if we could add a destructor so that anytime we wanted to profile a class, we could just put it in the destructor. So for the end of this point of the transaction, run this profiler method. But that is not in the cards, as it were. Let's make sure that this is working as we want it to now. So I'm going to do execute anonymous. And this will come back and say remaining queries 99. Great. So in a number of remaining queries, we should also do some things like percentage of CPU time or remaining CPU time. So what I'm going to do here is I'll just add this and I'll say remaining CPU time and put that there. Now there's other ways you could get this data. You can pull almost all of this out of the debug logs, but this is just a way of demonstrating what you can do with these limits methods. So what we're going to do here is we'll say, but we did a plus sign there, so we'll do limits dot get limit CPU time minus limits dot get CPU time plus. Okay, and we'll add that. We'll go over here and run it just for grins and giggles. Saving. All right, run this. Okay, and now we get down here in our debug logs, we get that. Oh, look, we've got a formatting error. Look at that. Somebody forgot to put in a like that. Okay, but we get the profiling data here, and you're going to see also that we get this profiling data. This is the standard stuff you get out of here, and as you sort of like work through where you'd want to use the limits versus where you want to use this standard debug thing, you probably want to use the standard debug thing more often than not. But I want to demonstrate how you can pull this stuff in, because here's where these get really useful. We're going to turn around and we're going to take a long-running process or something. We're going to artificially demonstrate how you might want to investigate these governor limits at runtime dynamically to determine whether or not to take an action. So here we're going to do public static void dynamically execute task. That's a really bad method name. Let's do check limits and determine execution path. Okay, so first one we're going to do is queries, because queries are nice and simple. So we're going to take and say we get 100 queries that we can do, 100 SOCL queries, and if we're going to run close to or go over, then what we can do is we can simply say stop, and do something else in, say, a future call or in a queuable. So what we'll do here is, just for grins and giggles, I'm going to put in this one. I'm going to annotate this as at future. Okay, you'll see why here in just a second. Now, what we're going to be doing is, oh hey, look, we got some. Yeah, Heiko is giving me the. Yeah, Heiko's giving me the calculation for the percentage there. But what we're going to do is we're going to go in our check limits and determine execution path, and I'm going to artificially hit a limit. Okay, so this is bad code. Don't do this. Do not do this in production. This exists simply as a demo. Okay, so the caveat there. What we're going to do is we're going to do a for loop, and we're gonna do this kind, and we're going to say for index I 0, I is going to be till we're going to say 101. Right? So we should be hitting this, and then what we'll do here is we'll say list account is equal to, we'll say this is T, select ID from account, just to make it speedier, limit 1. Okay, no big deal. We're just going to grab the account ID, but we're going to do this 101 times. Now, if we run this method as is, we should hit our governor limit. So let's go over here. Instead of doing this, we're going to call this method and clean that up. Don't need to do this one right now. And if we run this, execute anonymous, failed to run. Why did it fail to run? Well, as it turns out, I apparently didn't use the right method name. Oh, I didn't save the file first. That would help. Saving. Clear that up a little bit. Okay. Now, if you hit a governor limit, a hard governor limit, the transaction stops. Not such a good experience. Data may be rolled back. You don't want to deal with that. So what we're going to do here is we're going to make sure that we are throwing our exception. Here we go, close to limit when we get to that there. And then we're going to see that we hit our too many SOCL queries. Okay, so that's good. Now what we're going to do is we're going to go back into the limits class here, and we're going to make this a little bit conditional. And we're going to say if remaining, let's do this as a method. Okay, and actually, can we do it as a property? That'd be interesting. Public, this is going to be an integer, public integer, and we'll call this remaining queries is equal to get, like that, and doesn't like that. Why? Let's see here. Get should like that. Private set. It's a computed property here. Oh, you know what? That's because that needs to come out. Really? Okay. It doesn't like that. Okay, so we'll just do a method. Come down here. Private static void integer. And this is going to be remaining queries. Return like that. So if remaining queries is greater than 1, we can do this query. Oh, format already. And then if not, else, we can do throw no new. Let's give ourselves an exception. Public class limits recipes exception extends exception. Boom. Zippity doo dah. We come down here and go throw new exception. We'll throw new limits recipes exception. No more queries allowed. That. Now you may be thinking, well, why would you want to do that? Well, there are plenty of times where you've got something going on, a lot of things going on, especially in larger orgs, and you want to know whether or not a certain transaction is going to succeed. So before you do a DML or a query or something like that, you can actually check by doing what we've done here, that we've wrapped it in this remaining queries, to see whether or not you can safely make this query. Now if we come over here and we rerun this again, okay, it's going to tell us it failed to run again, and that's fine because we are throwing an exception. So let's go back here, and it's going to come back and say close to limit, system limit exception. Nope, wait, where's my... Did it not save? Did I not save it again? Silly Kevin. If this is greater than or equal to, actually we should say 0. Greater than or equal to 0. No, greater than or equal to 1. Yeah, I can type. Struggling today, apparently. Okay. Any more? No. Okay, nothing more in the chat here. So let's run this again. Failed to run. And too many SOCL queries. We're not getting our custom exception. What have I done this time? Okay, so during the for loop, if remaining queries is equal to 1. Oh, that's because it's CPU time. Duh. I did CPU time instead of queries. Where is my mind? Yes, that is a reference to an old song. All right, let's look at that. You should never, drink and call people. You should also never not get sleep and then code. All right, let's try that one more time. Okay, failed to run. But this time we get our limits recipes exception. No more queries allowed, and it seems we get it. Yeah, it got thrown up the stack. We're not getting it multiple times. It got thrown up the stack. All right. So as an example, when you're coding along and you want to make sure that your code is going to successfully and gracefully handle coming near a query limit, you can always check ahead of time. So it's not just the query limits that you can do. You can also do CPU time. So imagine a situation where you've got, or here, let's do this. What we're going to do is we're going to wrap this query in its own method. So I'm going to do @future, and we'll say public static void extended query limits @future. Okay, we're going to take this exact same thing here. Oop. Just wanted to copy it. Okay, and we'll do this. And actually, let's just do the whole thing here. Yeah. Okay. Now, I'm going to reformat this after I do that. But instead of throwing this new exception, what I'm going to do is I'm going to call limits recipes dot extended, not limits queries exception, dot extended queries at future, like that. So we're going to go 0 through 100 just fine in this transaction. And then what we're doing is by calling this add future method, we're actually going to do our last transaction there in another, our last call out here in another transaction. And any future, and if we had this to be 105, it would invoke this at future multiple times. So what we can do here is call this at future, and what we'll say is we'll save this and we'll go run it over here. And by making that call to an at future method, now we know that it should not error out. And I say that I'm jinxing myself here, absolutely jinxing myself. So let's go ahead and run this. Looks like it ran, and no bogeys, no bogeys, no bogeys. Now you see we hit close to the limit. We hit close to the limit, but not quite. Okay, so we hit close to the limit there. Very nice. So we came right up to the line of our limit, and then we turned around and we pushed that next thing to the next transaction using an at future. Now, at futures are kind of a ugly, I don't like them much. I like queuables much better. So if we were to rewrite this as a queuable, we have to think about how we're running our code and where things are being run. One of the things that I like to do is I like to think about how I can shift all of my processing to asynchronous. Now, there's drawbacks to that. You obviously don't want to do it if you're doing like a Lightning Web Component controller, but if you're talking about doing either, say, batch jobs, or you're talking about doing, things like callouts and integrations, that sort of stuff, I always try to push them into asynchronous classes. Mostly queuable, sometimes batches, but I'm a huge fan of the queuable. And so if we think about when we're dealing with a queuable and we're dealing with work that might hit a limit, then what we can do is we can turn around and re-enqueue that same queuable. So what that might look like is something like this. So let's create a new class. And I'm going to create a new class. It's going to be limits recipes queuable, and we're going to put this here. I'm going to give us some documentation up here what we're doing. This is a class demonstrates how you can re-enqueue QUEUE, there we go, queuable to skirt's not a bad right word, to bend, to prevent hitting govern or limits. Okay, so recipes, we're going to put this in the queuable here. It's going to implement queuable. Okay, we don't need that constructor, but we will here in just a second. And this one is going to be, this is going to be our public void execute public static. It's public static void execute, and this is going to be queuable context, call it QC. There we go. There's that method. Now we're going to have two different queuable constructors for this class. The first constructor is going to be our sort of no-op constructor. And we have to forcibly put this here because we're about to also give an optional constructor that takes one parameter, and that is going to be a list of accounts. So we can do public limits recipes queuable list accounts and we'll do this dot accounts equals accounts. All right, so we're going to do list accounts accounts. New list. I'm going to initialize it. I debated it, but I'm just going to do it. Okay, so we've got a list of accounts. Now, sometimes when you construct this queuable, you won't have a list of accounts. So you're just going to put it in here. Now, if you want to, we could even make this a little bit smarter. We could take that no constructor version and we can put in, you can say this accounts is equal to select ID, put name in there for good measure, from account, like that. Okay. Now, this is going to be really bad code, right? I'm illustrating how this works, but I'm doing so by by intentionally doing things you should not do. Okay. So do what I say, not what I'm demonstrating, I think is what I'm trying to get at. You know, that's a good pull quote for this for Twitter. Do what I say, not what I'm demonstrating. Okay. So we've got our queuable constructor that takes no parameter, and we have one that takes a parameter. And for our queuable context in here, what we're going to do is we're going to say for, and we're going to say account, and it's going to be ACCT, and we're going to put in this dot accounts. Okay, so we already have the makings of some bad news here because we're going to iterate over this dot account, and it's not going to like that. I don't think it needs to be static. Let me make sure. Let me look at the, how do I double check what my query limits are, my limits are for doing things like asynchronous? Well, we can go look at the query. We can go look at the public static void. It is static void. Ah, okay. Cancel. Okay. Limits recipe queuable. Why no likey? List accounts. Oh, that's because count is wrong there. There we go. Save that. Yeah, this is static. Boop, 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 boop. Save. Okay, so we're going to get this accounts. Okay. Iterate over it. Now, accounts, the list can contain up to 2,000 records. So if we were to do a query for more information per account, which you should not do, it might look like this. Name, shipping, street, like that. We're from account. Where ID is equal to. There we go. All right, so don't do this. It's bad news. Okay. Now, we're going to wrap this in our query check. So when we had our limits recipes, I put this one down here as private. I'm going to fix that. I'm going to say public. And over here, I'll say if limits recipes dot remaining queries is greater than or equal to 1, then take care of running this. Okay. Now, you know what? We're going to need the index, so we can't do this style. So we need to do integer I is equal to 0. I is is less than or equal to this dot accounts dot size, and then we need to say I plus plus. So we're going to do accounts. We're going to do accounts this dot accounts I. Okay. Now, if we have hit our limit, actually what we're going to do is we're then going to let's do it this way. Let's do account is equal to this dot accounts I dot accounts dot remove I. Yeah, let's double check that. So, wrong browser window. Apex list methods. Class. Okay, we're going to look for remove. Yeah, remove. Returning the element that was removed. Perfect. Perfect. So we're going to remove this current one. And we're going to come down here and we're going to say acct.id. Now, since we're removing it and we're iterating over this list, every time we loop through this, it should lose one. So if we get to the point where we're going to hit a query limit, else, right? Now what we can do is we can say limit recipes queuable LRQ is equal to new limits reasonable recipes queuable, and this time we can pass in this dot accounts. Okay, so we're passing into our constructor up here when we create a new version the shorter list of accounts. Okay, so now what we can do is we can pass that on here, and then we can do system.enqueue job LRQ, like that. Now, when this runs, this queuable runs, when we trigger it off without a list of accounts, it's going to what it's going to do is it's going to query all of the accounts. Okay. Now, just for grins and giggles, let's do this. Let's do system debug. Let's see how many accounts I have. We'll do select ID from account dot count, like that. We'll execute anonymous this. Failed to run. What's wrong with you? Count. Its size. I wish the programming language people of the world would just all get together and work and define on the, be like, okay, we're all going to use size. We're all going to use count. All right, let's see what this said. System debug. Execution started. Where is my output? Okay. I am debugging this. Where is my oh, 50. Okay, I got 50 accounts there. All right, so this is going to be hard to demonstrate, but we could write this in such a way. Let's see. Well, I think this is a good demonstration, but we need more accounts. So how could we deal with that? We could either do it in the test, in the unit test, where we just create 2,000 of them and then run this. Although that is going to bail because you can only run a queuable once. Proving that a queuable enqueued another queuable is a little bit difficult, but we can tackle that as we get to it. Let's think about this. Somebody said, "Thank you so much. I need this video. I arrived late. I'm sorry." That's fine. I'm glad you're here. Somebody else wants to know how I do this character, greater than or equal, and this is actually not. I'm a font nerd. Okay, so some people are like car nerds that really like cars. I'm a font nerd. I really like fonts. This is a feature of fonts called font ligatures. Let me just make a note here so people can see it on the screen. Font ligatures. And they are an alternative display of a multi-character string. So if I say greater than, or less than in this case, nothing happens. But if I say less than and then an arrow, or a dash, I get an arrow. Or if I do an equal sign, I get a less than or equal. Same if I do a greater than equal. There are a number of standardized font ligatures. Arrows, dot 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 is one of them. If you do plus plus, and they've been shown in internal studies. I think it was Microsoft showed that if you used font ligatures, it helped improve the readability of your code, and that led to less bugs in the code. So I'm guessing they figured out font ligatures sometime back around 2000. But they are big thing. I appreciate them a lot, and so I use them. It's a setting you can use inside Visual Studio Code if you search inside settings for font ligatures, and then you need to set it to equal to true. And the font that I'm using is a Microsoft font called Cascadia Cove, and they've done this is a fantastic font for programming and coding. I love it. Anyway, so back on topic here. We need 2,000 accounts. So let's do this. We're going to say this account equals, we're going to say, we're going to do list account to add. We're just going to do this for I and let's see, we got 50, so we need to do this. Let's see, 2,000 divided by 50 is a lot. It's like 20 some, I think. Give me a calculator. Let's do this. 2,000 divided by 50. It's 40. I was off by order of magnitude. 40 I plus plus. We're going to say this dot accounts is dot add all to add, like that. So this dot accounts should have 2,000 records in it by the time we're done. The 40 copies of each one, but that'll be fine. Okay, so now when we get down here, we're going to have this limit. We should hit this limit way before that. Actually, here, we can do this. We're going to hit it in 3. So we'll do 3, because it's not 2,000 that we're going to hit it on. It's going to be the third set of 50. And we'll save this, and we'll go execute it over here. Okay, and then it doesn't like this. Okay. Boop. Boop, boop. Saving. Oh, why no like this? Variables don't exist accounts. Okay. Well, we can always talk about it this way. If you're going to be mean. Phenomena. Uh-oh. List recipes queuable accounts. List recipes queuable. Public static. Savey. John Adams says, thanks for that tip. I'm assuming you mean the font tip and not the gloriously bad way of breaking all of your governor limits. Let's see. There we go. Okay. Yeah. Oh, that's a static variable. How did I do that in the asynchronous Apex one? Let's do this. Queuable with callout. We've got, it's a private static. And then our execute method, we are looking at throw error, which is a private static. So that should work. Let's do queuable with queuable chaining. Of course, I click on the metadata file. Okay. Queuable chaining. I've got list accounts. Good. All right. Well, that's in the execute method. And this is why. I've solved this before. How did I do that? Let's see. John M says, yes, it's the fonts. Okay. Public list. I won't allow that. I don't think that's going to work, but we'll find out. Okay. Yeah. Variable does not exist accounts. Okay, so it's just this one. And we're in a static context, so we're got an instance variable that won't work. That's the root cause of this. So if we construct this and we put that in there, how do we, let's look at the queuable interface. Let's look at Salesforce Apex queuable interface. Public void. It does not have to be static. I knew I wasn't crazy. Public void. Sometimes yeah, okay. We're gonna pretend that never happened. Oh, what do you not like now? Oh, it's because size is a method. There we go. You better save this time. Successfully ran. Alright, we'll get rid of that. Okay, so we've got this set up as a queuable. We've got this set up to fail as a queuable. And so let's go over here to our bit over here, and we're going to do limit recipes queuable. LRQ equals new limits recipes queuable. We're not going to pass in a list. And then we need to do system.enqueue job LRQ. Now, it's just going to enqueue this, which is not going to let us see what it is. So let's go ahead and open up our default org. Open default org. Loading. Okay, so what I'm going to do is I'm going to do a queue, Apex Flex queue. Okay, no records to display. I'm going to also open the developer console. Okay, we're going to look at logs that happen. All right, and now let's go back here and we're going to rerun these two lines. Execute anonymous. Row. Invalid type limits recipes queuable. Did I misspell it? I apparently did. All right, let's try that again. Okay, so that ran. Now we got, okay, got a lot of logs in here because you can see where we're adding everything. Okay, and if we come down here and look at this, we used one socket query out of 100. That's fine. We queried 50 rows out of 5,000 because we only had 50, or 50,000 because we only had 50 rows in there. And then what we've done is we've added a number of queues. So we've added one job to the queue. Okay. Now if we go back over here to our, got a queuable handler error. Let's open that log up and see what happened. It says my index was out of bounds. List index out of bounds. Let's look at the log. Okay. So over here, we're iterating over accounts.size, and we're getting account and okay. List exception, line 25. Line 25. Counts remove. List out of bounds. That's interesting. Why would that be out of bounds? Counts.size. Here. Adding all. Let's do some debugging. System debug. We'll do accounts.size. And just to make this visible, we'll put a little flag there. Save that. We've got 1 minute left. Okay. Gonna have to speed things up here. Got someone coming in right after me, so I'm going to go ahead and stop coding here because we've got 1 minute left. I don't want to cut them off of their time. Thank you all for joining me today. I hope you had as much fun watching me code typos as I had coding typos, and we will get this pushed to the repo for Apex recipes here as soon as I get some unit tests written. Thank you, and I hope you see the power of how you can use these limits methods to determine how you should execute code. All right, and I'll see you again next week.